Let's get started. Hey, everybody. I'm Andy Ballester. I'm the Chief Product Officer of EyePop.ai. The goal of the workshop today is we're going to learn about building a custom model on EyePop. Today, we're going to be building an object detection model that is finding an object, a condition, a quality, and actually localizing it within the image within a bounding box. We also have some different models that you can use that we'll not be going over today. We have classification models, which is just tagging images or frames of video. Um, Also a great way to video search images and videos is to tag them and to provide that metadata. So definitely relevant to what we're doing today, but we wanted to take a little bit of a different tack. We're also going to be using our custom model that we're building today, and we're going to be showing a couple different ways to search either a batch of images and sort them, or looking at frames of video and auto highlighting a video to just the parts that we care about. And so um, we should have a pretty good amount of time for questions and still get through the material today in the hour that we have. And so I'll stop at different pieces to just check in and see if anyone has any questions. And then afterwards, if you have any questions for me, it's Andy at EyePop.ai. Happy to talk through specific implementations that you might have or questions around implementation for your project. And so definitely let me know. We also have a Discord community that we are very active on. And so if you have questions, also respond during our Discord. I am going to take the, just first couple of minutes just to run through a really quick presentation on what is EyePop. I find it's good to get the basics out of the way before we get into coding. Promise I'll keep it short and we'll jump right in. All right, and so let me share my screen, and we've got code immediately. Great. All right. Everyone should be able to see a presentation. Good to go. Okay. All right. What is EyePop? And so EyePop is a self-service AI platform designed to make it easy for people and businesses of all technical levels to create apps and detailed analytics based on perception AI. We're going to be looking at computer vision today. And how does it work? We are, in a nutshell, we help you create a POP. And a POP is an endpoint in the cloud. It's got an AI worker server attached to it to do work, and it is running a computer vision recipe. And we'll talk a little bit more about what that means. And we'll also talk about POPs in other places. It doesn't just have to be our cloud. Later, we'll talk about it be your cloud or some edge devices. All right. So in this flow, uh, generally, we're always going to start with what is the visual data that we are interested in analyzing. And so when we think about unstructured business data in the form of computer vision, it's usually images, video, or live stream. Those images can be natural camera images, or they could be generated images, hyperspectral images, all kinds of data that looks like an image. That gets passed to our system via SDKs. We have great SDKs for React, React Native, and Python. You can also use our web APIs to build us into any systems. That flows into your AI worker server. That's your POP. That's that computer vision recipe running on a server that's capable of running these AI models. We respond back through the SDK with JSON data. That JSON data can be integrated into really any app or program there, and you use that to do work. And so whether it's to learn more about your users based on the data that you find inside of images, or actually change their product workflow or do some other analytics in the background, that's up to you. And so that's part of how you want to implement it in your product. To dive in a little bit deeper on what some of our computer recipes look like or pipelines, we've created a proprietary computer vision pipeline technology. It's very low latency. You can combine models at will, and we'll be looking at that today. And that's in order to provide you with a rich set of information. And so when we went out to the market and talked about real world computer vision problems with startups, what we found was one model often doesn't cut it for the type of data that they're looking for in traditional CV development. You want to combine models together in a way that makes sense, where you don't have to do a lot of back and forth calls. You don't have to put the visual data through multiple times. You want to be able to come in and use the response from your pipeline right away. So some of our pipelines are around lots of different common things. And so I'll speed through this because today we're mostly going to be talking about what happens when you don't find your object, condition, or quality that you care about inside of one of our default pipelines. But we have several pipelines around people, counting them, finding where they are in a scene, finding body landmarks on people to understand potentially in video over time. How do their bodies move? How do we analyze the parts of the body that they're expressing to the camera? We have a 3D face body hand mesh pipeline that will give you lots of information and meshes around person body parts. It's great for gesture detection, for identifying people's hands for control spaces, for using that face mesh for mocap, and other opportunities like that. People and common objects. This is a great starter pipeline to understand what is in your video or images. People and animals, people and devices, people and sports equipment, vehicles at the street level, text detection. This one, I'll stop and pause here. This one's excellent for finding products in real world. This is not just form OCR to figure out, hey, all the data on a really structured, well-formatted form. This is also to point a camera at for text in the real world, finding when it's curved, when it is misaligned, when it has weird fonts, handwriting, those types of things. We have traffic cam detection, slightly different from our street level view because of the angle and some of the other difficulties from traffic cam. You're often dealing with lower resolution, farther away, those types of things. So we have an expert model around that. Sports player tracking. This is combining several of our models together, understanding text on a person, understanding their relationship with things like sports equipment, demographic data around people. And then lastly, what we'll be talking about today is building your own model. And so one of the things that we don't detect by default is eyeglasses. And so we're going to use a somewhat trivial example, build a model around that and understand, like, how do we combine things together as well as use that custom object to do interesting real world problems and take a look at the data that we get out of that. And so in this example, this is the model that we'll be looking at today, finding the eyeglasses. And then I was able to, with a couple lines of code, just combine that with our person and 2D pipeline so that when I get my JSON result from my endpoint, I'm getting all of that data all at once, and don't have to make multiple calls. Some of the other things, and this is really why you want to use computer vision and object detection specifically, as finding things like satellite features. And this is a case study we're working on with the university around archaeological sites, finding conditions like fire, finding conditions like damage to packages out in the world, and then finding objects, parts of an object. So you can think of a car as an object, finding a part of a car, which is a tire, and then qualifying whether that part is how we expect it to look or not. And so in this model, we have a flat tire detection. So wide open in the amount of space that we can really take the concepts that we're going to be learning about today into lots of different industries and areas of programming. Lastly, this is the last slide, and then we'll get into some really fun product demos. We see the need not to just work in our cloud, but your cloud, on-premise devices, and also at the edge. And so we already have capabilities to deploy on-premise servers. In the very short-term roadmap over the next quarter, you'll be able to build and then deploy with one click your model out to iOS and Android devices, as well as your cloud as well. Okay, so let me stop sharing there for a moment, and I'll start bringing up some product demo. Any questions before I move into the product? Okay, excellent. All right. Let's move right along. Okay. Should be able to see my screen. What I'm showing right now is the EyePop dashboard. Most folks should have an account already, so you should have seen some version of this. In the EyePop dashboard, a couple of features here. I have my endpoints. This is one of the endpoints we'll be looking at today. An endpoint has a name, a pop UUID. We're going to be using that to interface with our code. I've also created an API key to authenticate my code. Now we could use the starter code that we give as examples here. And in fact, when we look at the code that I'll be using later today, this is going to be very similar in structure to what we've done there. We have Python SDK as well. You can do computer vision just with that much Python. One of the things that we're sharpening our pencils on this month is providing code sandboxing and Python notebooks to get up and running even quicker. So I'm very excited about that when that comes out. We also have plugins to allow for easy development into some no-code platforms or API-based platforms. Great. All right. So this endpoint, as you can tell, is around our eyeglass use case. I have some other use cases in here. This is and so let's take a quick look at how we would build an endpoint. It is super fast. We would hit create endpoint. We're going to be using API endpoints today, and so we're going to start creating there. I'm going to build a quick person with 2D body points detection. Let's do 2D. Here we go. So what this is doing on the developer plans and basic plan, it's going to pull one of our AI worker servers from our cloud, and then that's dedicated to you for a certain amount of time until it detects that it's going to sleep. In our production mode, we have dedicated capacity for you. And so those are your servers that it is interfacing with, and there's no warm-up time. I've chosen from our list here this person with 2D body points pipeline. I could start checking it out here, but we're gonna check it out in a different preview experience. And that's it. Now I have an endpoint I can start to do work against. And so this endpoint, I can read about it in the docs, the types of things that it will emit in JSON. But what I'm going to do first is I'm just going to preview it. And so let's check it out. All pipelines and endpoints, they work in 3 different modes. They work with images, video, and live stream. I don't have to do anything special there to make them work in any of those modes. The SDKs make each of those modes quite easy to actually put together. We're just going to send in some person data right now. I'll send a picture of myself. And so here I've uploaded an image into my AI worker server. We see that the round trip for one image to be about 100 milliseconds. And so you can get very real-time feedback around images. If you send them in as a batch, which our AI worker server is capable. You'll see a lot less latency on a per image basis because we're able to do some things in parallel on the other side. Same thing with video. You can kind of think about video as a batch of images. The other way we can use this endpoint is connect it directly to a live source. In our preview code here, we have it connecting into your webcam. And it uses WebRTC and WebSockets to make this connection. Let's take a look here. I'll pause it and let's take a look at the paused JSON here. And so this is the standard output that you'll see from EyePop. In here, you will get a list of objects found. In our classification models, you'll get a list of classes that are found, or tags. In here, we found one object. It is a person, and we can see that here. High confidence are our curated pipelines are very tuned for when they feel strongly. It's going to be high confidence. When they are not as confident, it's going to be low confidence. There should be a good separation there for you to use in your application. In here, we have key points, and those key points are represented by the visualization here: eyes, nose, different parts of body. When it can't see one, I have a confidence threshold in here by default. So where it's lower, where it can't see, for example, my elbows or ankles for that matter, it's going to filter those out. There's lots of different ways to compose this pipeline. If you want it to take some wild guesses on where those things might be that extend beyond the image, that you can do that and figure that out. Okay, so this is the format we're going to be looking at quite a lot today, of especially around this object and single object kind of format. So the same way we're going to detect eyeglasses, we'll find that here. In video, one of the things that our pipeline provides is this tracing ID. This ID represents that the person that it's finding in frame 1 is the same person in frame 2. It's watching the video and using geometry and other algorithms behind the scenes to track that person as they move through a scene, and even as they get occluded by other things. And so I know that this is one person, even though I'm going to see person over every frame potentially in this particular video. It's just one person, and their unique identifier is this ID 3. If there was another person in the scene, they would walk in and get a unique ID. Okay, so that's the basics of what we're going to be doing today around using our custom model. And let's jump into actually building a custom model. And so the first thing I did was I went and I prepared my data. And I have a set of about 600 images around eyeglasses. I'm going to create a new model. I'm going to build an object detection model today. And we're going to call this test eyeglasses. We're going to start, and I'm going to do a little bit of cooking show magic today just to jump through a little bit more quickly so we can maintain our workshop within the hour. But start to finish, these processes to build a custom model generally take between 1 and 2 hours. And so as you go in, especially your first pass, where generally that's a couple hundred images, we can build this out pretty quickly. Now, today we are just looking for eyeglasses, but we could add other labels here to potentially make this not just an eyeglasses detection, but a wearables or accessories sort of detection. And I could add things like handbags or other things I may wear on my face, like a mask or jewelry or something like that. Depends on the type of detection you want to do. So we're going to keep it simple. We're going to jump into eyeglasses today. The other thing I'm going to do to make this a very quick process for this first part is I'm only going to upload 20 of the images that I have. And so let me jump in and look here. Okay, we've got 28. That sounds good to me. Let's do that. So this is going to upload to our training system. You can see that happens pretty quickly. Behind the scenes, what it's already starting to do is analyze these photos and create something that we call a priority. And so I'm going to continue here. Normally, you would put more data in, and I recommend at least 200 for your first iteration of model. That can be good for a proof of concept. It depends on the type of object or condition that you're looking for here, but I would say that's a good start. So behind the scenes, we are prioritizing your images right now. That looks at things like how dissimilar are these images from each other. Models love variation. There's a lot of different things that we're doing behind the scenes to analyze those photos and make sure when you get to the labeling process that one, we're going to label this as much as we can for you in a way that makes sense so that you don't have to do a lot of work. And number two, that you're labeling the right things first. And so taking a look at our prompt, now we could change this prompt and we will in a second to mess with this, but I can tell right away it's being a little too aggressive on what it is looking at for eyeglasses. And so one of the things we can do is say, hey, don't give me all of your guesses. Give me some of your best guesses for what eyeglasses are. And we can see there are, this is looking pretty good around this 0.1 confidence. I'm getting a couple of extraneous boxes, but that's actually quite easy to handle in our auto labeling. We want to make sure we're getting some decent boxes around the things we actually want to label. And so here, let's shuffle these images again. Let's see how it's doing here. And so if we bring it back to that 0.21, we may want it a little bit higher for these. So I'm going to split the difference here. This is something that um, you can change later on and you can change it on the fly per image. So I'm not doing anything too crazy here. I do want to make sure I have the right prompt. And so for eyeglasses, this is looking pretty good. For some more complicated sorts of objects or qualities, like for example, I was doing a fire detection image model this week that I was training. I started off with fire as my prompt here, and it did okay. I found that it was a little bit too aggressive on what it considered fire. When I said just flame, flame actually like reduced it to just the flame part of the fire, which is actually more what I was looking for. I was just looking for active flame instead of things like smoke or other things associated with fire. And so our auto labeler here, it's going to do its best. Um, but there are situations where you do need to wordsmith this a bit to get the right prompt in there. So this is looking good. I can hit, I'm ready to auto label. It'll go through my image set and actually start to auto label them here. And so you can see it's gonna start with prioritization and then it'll start auto labeling my actual images. And so this is pretty quick because we only have 28 images. But let's go into a bigger set and actually look through what we may need to do there. So 1 second. Okay. What I am seeing here is after the auto labeling process, we now have a prioritized set of images. This is my real data set. I have over 500 in this particular data set. Of course, I want to take as much work out of this. I don't have to draw like hundreds of bounding boxes by hand. If I can do that in a smoother fashion, that's great. And so I can see how much of this I've labeled. This is a brand new, freshly auto-labeled data set. The priority of these first images is going to be high. These are the images that are most important to label for my model. And so these are the ones we're going to start with. I can use keyboard shortcuts to navigate through this. I find left and right very handy for scrolling through my set. And then I can look for the labels we're looking for. This is a very easy model. We're just looking for one thing, which is eyeglasses. So as I look through my images, the first thing I want to think about is what is an eyeglass to me? What do I want the model to actually label at the end of the day? And that sounds like a crazy question to ask, but if we take a look at this particular image, I think it highlights it very well. And so the auto labeler here is suggesting that we label the entire glasses. So basically anywhere you find pixels that are associated with these glasses, let's put a bounding box around the entire thing. Now that is great if I want to label glasses plus the stems of the glasses. Maybe my concept of glasses is it has nothing to do with the stems, and I'm just looking for the eyepieces. And so in that part, I may want to adjust this box here and fix it to just address the eyepieces. Now I want to stay consistent over my entire data set. And so one of the things that I may want to think about is if really what I care about is the eyepieces of the glasses here and not the stems themselves, then maybe I want to go back and actually like re-prompt and re-auto label this with a different prompt around the actual like spectacle part of the glasses, the lenses there. Um, but if I concur with kind of how the auto labeler is seeing glasses as it should be stems as well, then this is great, and this is what I want to start auto labeling on. So lots of information. Before I move on in the human labeling step, does anyone have any questions about anything so far that we've talked about? Okay, great. All right. So pretty simple so far. So let's start from the beginning. When I start to take a look at my image, this dotted line denotes that it's an auto labeled image. Just like before, I can ask it to give me more auto labels or less auto labels. In this one, it's pretty confident that that is the only one, depending, regardless of the confidence threshold I'm giving it here. For example, in this one, if I bring that confidence level to 0, this is all the guesses it has. So it has quite a few guesses. We want to bring that to some of its most sure guesses here. And so we can see it has two different guesses there. Um, Starting with this one looks great. No notes. I can either hit A for approve. I can hit S for save. And then once that is done, I can see it changed from unknown in the tag to known. I can see a solid bounding box. This represents something we call ground truth. This is a human approved label, and that is now included in our training set. So I would just go through and start approving. This looks good. I don't want cartoon data in this particular model, even though I have it in some of my source data. I won't find that useful because we're going to be looking at natural images with this particular model. So I'm going to ignore that. That just takes it out of the training set so that I don't need to worry about it. Um, Great question. Do I think these are glasses? I would say, yeah, sure. I would want to find those if I had it. The auto labeler got this box, so I'm going to leave that box alone. I can also add a box to this just by dragging into the interface here. And so those two boxes represent the two glasses in there. And you can see I've got my box tight to the pixels represented in the second glass. They're overlapping. That's fine. Doesn't matter. In fact, we want the model to understand when objects overlap. In this one, obviously that bigger box I just selected and typed delete to take that out, but it's ready to save. Save, delete, save. That one's already good. Good. This one, maybe we want to play with the confidence threshold here. We can tell the reflection of the glasses is really causing it some concern there. And so in here, this is a good question. Do we want to count reflections? It's generally you want to treat reflections as the object that you're doing. Depends on your data though, and depends on the model performance of what you're looking for later. If you really don't want it to treat reflections as the actual object, you can try to teach it that there are things that are shiny surfaces and um, don't count the reflected version of that object. It will learn that. You may need a little bit more data. There's only a handful of situations where that actually matters. In this particular one, I'm just gonna save it here and move on. And here, let's see, that bounding box looks pretty good. Um, in some of these images, I may need to zoom in. We have, pinch to zoom. We also have other shortcuts where you can zoom in scrolling the mouse and doing some other things there. So try to make this as easy as possible um, to just continue to work through pretty quickly. And so with these auto labels being pretty decent, I can work through this fairly well. And so you can tell you can get into quite I can hit shift and select multiple boxes at the same time and delete them. Um, you can get into a rhythm, and for a simple image set like this, I can generally label a couple hundred images an hour. And so this moves pretty quickly. So any questions about this particular interface or how you would approve human level images?
Yeah, is there a guideline or rubric on the number? I mean, you've got hundreds in here, right? So
Yes.
I can't imagine doing that. I'd just shoot myself before classifying or tagging 400 images, right?
Yeah, it goes really quickly. You have some dumb TV on the background, and like an hour later, you find you've done like three, 400, and it's no big deal. We also have labeling partners that are willing to work with you, especially in bigger use cases. I would qualify this for as like proof of concept or beta level amount of data. I generally want, in the thousands for something I would use like out for users. Especially, and you want to get there iteratively. You want to understand like where are the edge cases of my model and add specific data around that. So if you need help, we have labeling partners that can come in and parachute in their expertise on labeling. But actually, I found this to be a pretty relaxing process overall to do. It's you can whip through it pretty quickly. We have a guide here that is our how-to of some general tips around how you want to label and how some of the things you might find helpful there.
So you're saying for prototype under 1,000, for production, you're going to want to definitely go higher than that.
Yeah. The
Uh,
next thing though is you can see the auto labeler, even using the confidence thresholding, it gets a little wild on the guesses. So you may want to just start with 200 images, train a model. What will happen then is the model you've trained will also auto label anything left in your data set and any new images that you add to the data set. And so you can really refine the concept of what this auto label is. And it gets easier each iteration because your model is getting smarter and smarter. And so when you can really trust it, you can just really kind of review, tap A, and like you're really rocking through here. And so you get going pretty quickly. Okay. All right. So that is that process when you are done. And so here's a slightly bigger data set. This is the 12th iteration on this particular data set that I've worked on. Um, I'm going to training, and we give you a little bit of a sense of how well this model is going to perform. So number one, we look at how many images you have, how many are in your approved data set. So that's this checkbox here. And so we can see there's still more images I could label in here. We take a look at negative examples, and negative examples are really important in a lot of use cases. And what those are, and let me see if I can try to find one. This is a great example. Um, let me hop a little further down our data set here. And we will find a good great negative example. So in this particular example, there are no glasses. One of the things that my model in the first pass, and you can see these have not been labeled yet. These are some of the images I have not added to the model yet. But one of the things I've struggled with in the very first pass is I didn't have any examples of people without glasses on. And so every person had glasses that was a person in my data set, and it was getting very mixed up with the concept of what a person's eyes are versus what glasses are. And so what I did to combat that is we can look at an image like this, is we added examples of people with eyes that don't have uh, that don't have glasses on. And so here's an example of a negative example we've given to the model. None of these folks have glasses on, and so it can get a sense that, hey, eyes are not glasses, glasses are glasses, and that's a different, distinct object from the eye region. And now my model performs a lot better at not producing false positives around the concept of the eye region. There's you'll run into a lot of use cases, especially some of the more complicated objects that are out there to detect that are more amorphous. You want to give them good negative examples of pictures with none of your objects in them, or when you're doing multi-class, like for example, if I was looking at eyeglasses and handbags at the same time, those can serve as negative examples for each other. A person can be wearing a handbag and not glasses, and vice versa. And so it gets a sense of typical confusers to your model. What are good examples of what eyeglass isn't, And so, and just like people learn, having examples of what something isn't is great for models as well. So in this, I've got 20% as negative examples of my data set. That's a healthy percentage for an object like this. For some use cases, we recommend at least 10 to 20% is a good range to be in. For really subtle or amorphous things, you may want more. And we for the satellite data image set that I had been working on last month, um, we were looking for archaeological sites that are very amorphous. They have a lot of typologies. You can, as a human, you just know what they look like, but you have to train the model and to understand that. And so the first model got hung up on a lot of things that were not those archaeological sites by giving it examples. And my negative examples in that one was actually closer to 60% of the data set was negative examples of what not to say is an archaeological site, that allowed us to get much better results. And so here I'm ready to start training. I hit start training. What will pop up is an augmentation quiz. Augmentation is a way of messing with your visual data such that it produces a better model, a more robust model with less data. And so you can get the model performance of quite a lot. Like it acts like a model of more data if you can add the right augmentation. And so for eyeglasses, does our object make sense in black and white? Yes, of course. Does it make sense up and down? Yep, they're still eyeglasses. Laying on its side, sure. Blur or noise. This is a complicated one. Generally, I put if it's a natural image and it's an object and I expect it to be taken from camera phones and lower res, then I want to say a little at least. If it's something like, if we go back to that question, a barcode or something very specific, and I even found in things like hand signs for American Sign Language. It's very blur dependent. Even in that one, it's a little, yes, is a little bit too heavy. And so here's something, these are things that you can play with, but they're fairly common sense. Can eyeglasses be behind other things? We're getting at the sense, can it be occluded by something else? And yes, it definitely can. From a moving camera, I definitely want this to work from a cell phone. So I want to add specific motion blur to my augmentation data set. Can it exist outdoors? We get graininess, we get weather change, we get color changes in this one. So definitely far away. This one, I probably could have said, I could say yes or no here. It depends on how I want to use this. Typically, this particular model is not going to be used far away, but it can come in a variety of sizes. We know that people can be further and closer to the data, to the camera. We have different sizes of glasses, certainly. So I would say in this one, either yes or a little. Let's try a little, and that's it. 10 questions, very easy. Try to make them as simple as possible, and we can start training right now. When we're done training, and let me hop out here. Let's go to an already trained model. You can see some of the models that I have. This one is a model that's done training. We're going to hop right into code after this. Um, I can see number one, how well did it train? And so this represents the precision versus the recall over the confidence curve. And that's a lot of new terms. And so number one, the precision is how well, when it found eyeglasses, were those the only eyeglasses that were existed in our validation test set? And so it's testing the model that it's not giving me false positives. Um, Opposite on recall, how well does the model, when it is looking at an image, find in our test set, and all of the testing happens automatically behind the scenes, how well does it find the glasses in there, regardless of whether it gives us false positives or not? I want to know that it's at least finding the examples of glasses in there. And so by optimizing for both of these qualities, we can start to understand how well this model is doing. If we look at this, this is the confidence curve. And so from low confidence to high confidence, this way I can find like where that knee of a curve is. And around here is probably a good balance point. For my particular use case, I may be sensitive to the model giving me false positives more than I am worried about giving false negatives. And so I want to, we'll take a look right now of how I get a more qualitative sense of this confidence threshold. When I deploy my model out to EyePop, I can deploy it in the cloud. When I deploy it in the cloud, I can deploy it with other pipelines. I can say, hey, also give me a person with 2D body points. I want both things together because maybe I want to know if the person's wearing the glasses and understand its relationship to the face. They could have it, off to the side or some other thing. I may want to find text on those glasses or track them separately. But I can go ahead and create a pop and that deploys out to the cloud immediately. We also work with Qualcomm's AI Hub to optimize models for Snapdragon devices. This model I've already optimized for the Snapdragon X Elite, which is a laptop device. And so it gives me a Windows runtime to run my model. And just like I would access it in the cloud, I could run it locally to the device as well. So here, let's create a POP. So what it's doing is it's gathering an AI worker server, just like in the create POP process, and giving us an endpoint around our new model plus person with 2D body points. And it's spinning up right now and going to bring us to our preview experience. Let's go back, but let's dive in real quick here to the code because we're starting to run out of time. And so the first thing we're going to use our code for is in Python, we want to use this code to sort images by an object. And this code you'll get access to right after the video. This allows us to take an input folder full of lots of different images. We have images where there are no eyeglasses. We have images where there are eyeglasses. And so um, we want to sort between those two things. So a really simple use case where we're finding the object at a certain confidence level and we're either going to put it in the has object directory or has no object directory. We're also going to cache the output and so that we can take a look at it if we wanted to resort these later or maybe change our confidence threshold or do something else, we don't have to reprocess those if we have saved the output to a JSON directory. I'm going to loop through all of these directories and make sure we have those output things. I'm going to use image extensions to make sure we're just looking at images in this particular example. We're going to instantiate our endpoint. I'm going to use that pop ID that we have from the dashboard and our API key to authenticate. And we're going to loop through and process these on EyePop. So let me run it real quick, and then we'll step through some of the more of the code there. All right. And what this is going to do, because I have not been running this endpoint, is it's going to take a moment to warm up the AO worker server. So just like in the initial pop creation process, and then now we can see it's ripping through all of my images. I have roughly about 50 in here, and so it ran through 50 that quickly. And what I can see here is like all of the data that's come through here. And so for this particular image, this file name, it did find an eyeglasses object. It shows me where it is. We could use this information to visualize that bounding box on the image itself. We have in the SDK some great visualization code. And because it both found the object and the confidence of this eyeglasses was higher than our 0.85 confidence threshold that we had above right here, or 0.75, excuse me. It's going to copy that image to has object. And so let's take a look. In our output directory, we have has object here. And so these images we would expect to have eyeglasses. Same thing in the no object. We would expect these images to not have any eyeglasses in them. And so it's a simple way we can use object detection to actually sort through a batch of images. I have one last demo, but before I move away from the Python, does anyone have more questions about how we look at this? So just to call attention to some of the things we're doing in here, I'm doing simple caching around JSON. If we have the JSON already loaded up in our JSON directory, well, we don't need to load it again because we already have that for this image. So skip the processing with EyePop. That makes subsequent loads very quick. And I often find doing some level of caching really great for development because you're often processing the same folder or file or video over and over. Um, if we don't have that JSON, we're going to process with EyePop. Very similar to the code that is on the dashboard for my endpoint. I'm going to take the endpoint we have that we configured above. I'm going to upload my local file to it. I could also use here the from directive and function if I want to use a URL source, so a source out there publicly accessible on the web. It doesn't have to be on my local computer. We have other workshops where we talk a lot about live stream, and so you could do all of these same things for live stream as well. And then predict. Predict is what's going to give us our result. That's what we're dumping out to the screen, and that gives us our result that looks like this standard EyePop JSON. We can see in some of our images, there's no objects found. And so for this one, this represents an image that we did not find any eyeglasses in. And so that's what that output looks like there. So what we're doing then is taking the JSON and processing it. First, we want to make sure we found the class label. Object label in this case is eyeglasses. We want to make sure when it finds that label, it's higher than the confidence threshold that we're shooting for. And we want to make sure we found some objects in there that meet those two requirements. Now, there's a lot more we could do here. If I wanted to figure out, hey, which frames has a person with their hand up, or where a person is wearing the eyeglasses versus has the eyeglasses somewhere in the scene. This is where we would put that logic. We can really get very granular with the post-processing logic that we put here. But once I've determined that it has object is a Boolean, we then either put it in one directory or the other. That is the Python use case we're doing today. I'd like to switch over now to React. In React, we have a use case around what if I wanted to take a video and auto highlight it to just the frames that we know the object exists in, or and you can get really complicated with this. I want to make sure that there's a person in there and the object, or that the person is wearing the object in some way. Um, let's look through that. So I have in my code this turned off. So let's just look at what it looks like by default, and we'll switch over here. I'm gonna refresh my example, and this is a React shell. I've got our console up on the right-hand side here. I'm going to put in an image, or excuse me, I'm going to put in a video I took earlier today. This video I've cached the results for, and so that's why we're getting instant results here. For video, you'll generally get results in about half to the amount of time the video takes. So if this is a 30-second video, it actually took about 15 seconds to process this video. Depending on the pipeline that you're using, it may take a little more or less. And it's dependent on video time. If you use our SDK, there's actually ways for you to direct, hey, I don't want 30 frames per second. I want 10 frames per second. That's going to cut down the amount of time to process. There's lots of optionality there. So that was our video in its entirety. You can see there are parts to that. Let me narrate it as we go through one more time. Clearly, I have glasses on. We are visualizing the bounding box on these glasses using the SDK right now. I have a fairly higher or confidence threshold on this particular one. It's at 0.85. So you're going to see a little bit of flickering. We could fix that with a slightly lower confidence threshold. There's also other visualization techniques we could do where we know that eyeglasses don't pop in and out of existence, so we could give it some kind of visual inertia. And so in this video, there are, for about half the video, we are seeing frames with eyeglasses in them, for about half not. And so if I turn this to true, I wrote a small function to look for, are there eyeglasses in the current frame we're looking at in the video? And when I go to process the next frame of video visually, uh, is there going to be eyeglasses? And so we're gathering all of that data to start with, and then we're allowing the video to play itself based on which frames have eyeglasses in them. And so now that I've turned this on, I can then re-put my video through that. And what we'd expect to see here is it to skip all the boring parts without eyeglasses in them. And so here we can see we've got eyeglasses here. There was a big skip there where I took it and put it off frame. As I jump out of frame here for the rest of the video, we can see we've reached the end of the video here. And so um, this is important because there are a lot of situations where we have too much video data and we want to cut down to just the important parts where we find an object, a condition, a person doing some particular thing. And we want to make sure we're only bringing human attention to those most important things. And so some of the quick examples that we can think of are, sports highlights, esports highlights, emergency detection. And so we could use, like finding fire and video, insecurity video, and putting those together to bring attention to specifically what's happening there. We have clients that are using a lot of drone footage. They don't want 8 hours of drone footage. What they want is the, cut down 15 minutes where they're actually drone footage of roofs with some sort of damage on them. That's what they care about. And so we can bring human attention to specifically the parts we care about. So just like in Python, the way we set this up is we created a worker endpoint. Very fast to create worker endpoint here. looks a lot like the Python experience. The renderer is a little bit more extensive in its functionality here. And so I use a more decorated renderer here. That's how we visualize those boxes on the frames of video itself. When we process the video, again, I'm using a cached approach. So I'm using local storage to cache the frames of video, the results of the frames of video from EyePop. If I see this cached data, I'm going to use that. Otherwise, I'm going to process the video file through EyePop. Very quick to do. Again, I pointed this at a local file. Could also point this at a URL. And we wait for the results. We push each frame of video into a buffer, and this acts as our results buffer that we can then look through. This all happens up front as soon as the user selects the video. Once we have that buffered and all of the results in there, we can then start playing the video. When we play the video, each frame, what we're looking for is the closest prediction in the buffer to that frame. And so we have a helper function here that does that. It's going to use the current time and to I think 6 figures in JavaScript to find the precise frame that we need to be looking at. I'll skip over the skipping logic for a moment. We're going to take a look at all of the objects in that current frame that we found. We're going to make sure we're applying our confidence threshold filter, and then we're going to draw the current frame. And so that's how we're visualizing. When we turn on the skip frame object, we're giving it a class label and a confidence threshold. And it's making sure that, hey, I just played a frame. Let's look ahead to the next frame. If that frame doesn't have our object, let's look ahead to the next frame, and let's skip right to the next frame in the video with that particular object. All right, great. So we'll send out the code to everyone so that they can take a look at how these demos were put together. If you have questions on how do I create my custom object model on EyePop, please reach out to me. Happy to ID on that. Thanks a lot.